If I had to pick a point in time for why be a scientist, I was standing in the backyard of our farm sometime in the 50s, and Sputnik went over, the first satellite. And my father would point up in the dark sky and point and say, "That's Sputnik. That's what the Russians are doing. You need to go to college and participate in catching up with what's happening in Russia." When I came to ASU, I was given an endowed professorship funded by Florence Ely Nelson. I plowed that money into the first studies we did of vaccines produced in plants. And it was at a time when the ideas we were generating were crazy enough that it was hard to get funding from the federal government. That is, they were sort of outside the box. And having support from an endowed chair at ASU gave me the flexibility to hire some people, students, to try some new ideas. And fortunately for us, it clicked. It really worked well. I was taking a weekend off in Thailand. It was there for some collaborative research. Went to the river market where the boats come in, and I saw a woman with her baby buy a banana, peeled the banana, and gave it to the child. And I thought to myself, what can I do to re-engineer a plant so it has direct medical purpose? In talking with one of the professors at Baylor, we pulled together the idea, let's produce vaccines in plants. And we jointly did the very first project on a hepatitis B vaccine. And when we tested these plants, they produced an abundant amount of the structural component that's used today in the hepatitis B vaccine. Few scientists in their career actually see something that started on the bench and goes on to have an impact that's tangible. And you can make a straight line connection between the two things. So it was in 2014, one of my colleagues in San Diego that we'd collaborated with called in the morning. I was sitting in the kitchen, and he said, "I don't know if you heard the news, but there's an Ebola outbreak, and we sent some of our ZMapp," it was this drug we jointly developed for Ebola treatment. We sent some of this to Liberia, and they've used it in some missionaries. We designed it here at Biodesign Institute, and our collaborators in San Diego and collaborators in the U.S. Army carried it forward and tested it, and it worked. That's amazing. I think everyone needs to be shocked with new ideas occasionally. Something that changes your day-to-day thought process, and all of a sudden, bam, that's really exciting. I had no idea that was happening out there. So the idea of a Grand Challenge lecture series was bring in new ideas, bring in the cutting edge of science, and create the opportunity for our students, the faculty, everybody in biodesign to interact with this, with the ideas, and with the people bringing them to the forefront. I'm Charlie Arntzen. Welcome to the Arntzen Grand Challenges Lecture Series.